Number 4, we are going to evaluate functions using our calculator. We got to learn how our calculator works so that if we're in science class and we have to figure out the answers, how can we get the answers? So, if the rate of inflation is 3.9% per year, the future price, P of t in dollars, of a certain item can be modeled by the following exponential function, where t is the number of years from today. P of t is 1.039 to the t power. We want to find the current price and the price 8 years from now. Well, the current price, the time is going to equal 0. 8 years from now, my time is going to equal 8. So I'm going to have 3,000 times 1.039 to the 0 power, right? To do an exponent here, we're going to use the caret key, so that's how we're going to type that into our calculator. We might be able to do it without our calculator because we should know what something to the 0 power is. Anything to the 0 powers always equal to 1. If I would do 1.039 caret 0, guess what? I get a 1. 1 times 3,000. Okay, it's being goofy on me again. Move my board back. 1 times 3,000, going to give me 3,000. Why does it want to do that? Now I didn't have to do that in 2 steps. I can just punch it in like I wrote it. 3,000. Parentheses, 1.039 caret 0, close my parentheses, and if you hit equals, sure enough, we get 3,000. So current price of my item right now, $3,000. Well, my price from 8 years, it's going to inflate. It should be higher. It's going up by 3.9%. So I'm going to do 3,000 times 1.039 to the 8th power. And I'm going to punch that into my calculator. 3,000 parentheses 1.039 caret 8, close my parentheses, and I get 4,074.2308 da 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 da. We are rounding our answer to the nearest dollar. So I'm rounding it off. There's a 2 behind there. So 8 years from now, $4,074. Okay, so not too bad on that one. Notice the T was inside the parentheses here, and so we kept it inside the parentheses when we did our calculation. Number 5. I'm doing number 5. The radioactive substance, uranium-240, has a half-life of 14 hours. In other words, every 14 hours it splits in half. So if it started at 10, it'd be down to 5. If it was at 5, it'd go to 2.5 every 14 hours. The amount of sample of uranium-240 in grams after T hours is given by the following exponential function. 1,200, it's a half-life, and that's why the 1/2 is here, and then it's to the T14th power. Now on your calculator, if you have a fraction, it's best to put the fraction in parentheses so that the calculator knows you have to put that together. So I'm going to find the amount after 11 hours and the amount after 60 hours. I'm going to do 1,200 parentheses 1/2, close my parentheses, and then I'm going to use my caret key. Here I'm going to have a fraction, so I'm going to put the fraction in parentheses or it won't come out correctly. The T is 11. So I'm going to do 11/14. So 1,200 parentheses 1 fraction 2 1/2 caret in parentheses 11 fraction 14ths. Close my parentheses. I get 696.077. I want to round to the nearest gram. So I'm going to round it off here to 696. So it started at 1200. After 11 hours, it's at 696. Because I'm not quite to half, 14 hours would be the half-life. And I didn't quite go to 14 hours, so I have a little bit more than a half left. After 60 hours, same thing, 1,200. I'm doing a half-life, and this time I'm going to use 60 14ths for my fraction. So 1,200 parenthesis, 1 fraction 2, 1/2, caret, and in parentheses, 60 fraction 14. Close my parenthesis. I get 61.525. I've got to round it to the nearest gram, so I have to round that one off to 62 grams. So after 60 hours, I only have 62 grams left. Number 6 looks like it's also doing a half-life. The radioactive substance cesium-137 has a half-life of 30 years. The amount of time, or the amount in grams of the sample remaining after 2 years is given by the following exponential function. So, 621, the half-life, and then t to the 30. The 621 is the amount you started with. We're doing the half-life, and the 30 years is how long it takes to do the half-life. So when they have that set up, we're going to do 20 years and 50 years. So 621, we're doing the half-life of 20 out of 30. So it didn't quite have enough time to do the half-life because we didn't quite get to 30 years, right? So we should have more than half left over. Let's check her out. 621 fraction 1/2 to the 20 over 30. Close my parentheses, hit equals. I get 391.20, and rounding to the nearest gram then, after 20 years, I'd have 391 grams left over. After 50 years, well 50 years is more than 30, so I should have less than half of my 621 left over. 621 doing the half-life of 50 out of 30. So 621, half, caret key, in parentheses 50 over 30. Doing my calculation, I get 195.60, so I've got to round that off to 196. So I started with 621. After 20 years, I'm at 391. After 50 years, I'm down to 196.